Let's talk about dynamic memory management in C++. Earlier, we showed you how to create date object. When we're using the date and the object name, call the constructor function. For these two, actually we're using the static memory to create the object. So that's why after your program finish, you don't need to worry about that. The compiler will release the memory, so all the static memory will be released. We don't have any memory problem. But sometimes the static memory, when we run the program, they are faster. But sometimes we may not have the flexibility to change the information. So once I create the date one, this date one object always have the fixed location for the specific memory in the hardware. So sometimes if I want to make the memory location change, or sometimes our static memory is not enough, we need to create the dynamic memory. So to create the dynamic memory, actually you were using the new keyword and the delete keyword to create and release dynamic memory. So you need to use these two keywords to create and release the dynamic memory. And moreover, besides that, we need to use the pointer to access the dynamic memory. Okay, so for example, I want to create a dynamic date object. We can create the date object, but you need to create a date object pointer reference. So we just say here is the dptr. So then using this pointer to refer to the dynamic memory. So in order to create a dynamic memory, you need to have your new keyword. So the pointer refers to the object, but this object we need to use the new keyword. So then since the object name is date, I call the constructor. So we just say April 5th, 2020. So here actually you're using the new. So this object location will be in the dynamic memory location. So then you're using the pointer. So your pointer, since you want to refer to the date object, you need to create a date pointer. So after you have that, you have date pointer to refer to the object. So after you create this pointer, right? And later I find out actually I don't want this object anymore. Instead, I change the date. One thing is, if I don't need this object anymore, when you're using the new, you need to using the delete. So when you delete, you will delete the pointer. So it's not delete the pointer, actually delete the memory location where the pointer refers to. So that's why here you will have your delete keyword. Okay, so this pointer will refer to the location. So we see, for example, when you do the new date, right, you create an object here. So that's why we have our dptr point to this location. Okay, so this one is your date object. So then we're using the pointer. This pointer refers to this location. So then when you delete the ptr, they are not delete the pointer. They delete this where the location the pointer refers to. So they delete. So when we say they delete, actually that means they release this memory location. Okay, so afterward, can you create another one? Yes, you can. So for example, if I create another object, okay, so here I can create another object. Okay, so that's the second object. So what we will do is, let's do the join finish. Okay, so after you release that memory location, right? You can continue to do that again. You can have another dptr. Since you release the memory location here, you can create another one. I create the date. Okay, so then January 1st, 2020. Okay, so actually here is our January 1st, 2020. So that's why here we refer to this pointer, refer to the new object. Okay, so this one is 2020. So that's the dynamic memory allocation. So you need to remember whenever you use the new, you need to use the delete. So here you can see you can have a date pointer to refer to a new date. You also can have this pointer to refer to a date array. Okay, for example, I can create the 5 date object, so point to that. So if we do that, what happens? They look like this. They look like actually I have 5 objects. Each one is the date object. Okay, so each one is the date object. But then I'm using the pointer to refer to this one. Okay, so this one actually, when you're using the array object initializer, so we can do is we can do our date. So each one you can give them the object information. So we continue to have the 5. So when we do this one, that means you have your pointer to refer to the whole array reference. So after you're done, right, you still need to release this memory, right? Before you can just delete the pointer using the pointer. When you do the delete pointer, you only remove that object location. But then when you do the pointer, your pointer also can refer to an array. So when we do the delete for the pointer, you are not only delete dptr, because now the dptr, you are referred to what? You are referred to an array. So compiler needs to know more information. So that's why when I'm using the dptr to refer to this location, right? If you don't have the array symbol, they only release the first one. But if you do the array symbol, they will release the whole thing. So that's how you will use the delete keyword to release your pointer, but this pointer actually refers to the array memory location. So that's a dynamic memory allocation. So the next one, I want you to download the example. This example actually is under the date object folder. You're still using the date .h file and .cpp file, but this one, the driver program is different. They are example for driver program. So this example will show you how to create dynamic memory using the new keyword to have the string object. And also you can create a date array. Okay, so did you see you have data array? As long as you use a pointer, so then associated with the new, you are declare a dynamic memory allocation referred by the array. So then you can assign and display the information for the location and each object information. So be careful when you're using the pointer refer to the array. When you release the memory, you need to use a delete array. So then the same thing here, if you just want to release only the pointer refer to one object, so then you don't need to have array symbol. So you can try to modify this example to see what's going on for your result. So that's the result for each one.